What about you? You mean class 3 is good? And good afternoon to all of you. We start the discussion with a little more for other students. Do you have any questions from previous sessions? No? Okay. Session 15. In the name of God, the session about 2 or 3 or 4 sessions. We have started the studying of neural network, and we reviewed Rashid book. I don't know you study this book, but it is too interesting, and then said that oh, you studied about, for example, 30 pages. Just very simple and very simple and clear sentences. He explained the neural network. At first, I only review what previous sessions, and then follow it, because maybe some of don't have reviewed the as you say, see here, you see here, after the event in part 1, they explains about some concepts and nodes, neurons, backpropagation errors, waiting updates, and like this. Very simple way explains that using the previous part, he explains the comments in the neural network in Python. We also follow this content, and that have time, we will review the deep learning. I think we have time. We'll have time to read the stuff for learning deep neural networks. Okay. The first question is that, and the first is that we said that okay, in human, when we see question, we think and then answer. Computer also we feed input, and then after that the computer does some processing, and then we have output. But the goal topics in this book is the classifier again, and then he about a very simple example. For example, he considered how we transform the kilometers to miles. At first, he guessed it a linear relationship, input and outputs, and try to find the best calculating the error. He tries to find leadership. And then after that, groups we said about the class. But in this book, step by step, if we consider all of them, both of them are in one fit. We have, I explained in details in the videos, but said that okay, if we have some example using examples, we can correct a linear classification. And then again, but by seeing error between the desired line and this calculated value, then updated the slope of this blue line. I outline this. I only want it. Then after calculating the final refinement, final line, then can moderate this classification, because if you attention, this line is too near to red object. Okay, introduce a moderation way, a method is how we moderate this line, and then after that we achieve this. The equation, the mathematical relationship is in the book, and also I explain And then after that, okay, sometimes, for example, if this data is related to logical and this line can separate and red circles. If we have all, then we can one line. But if we have XO line, it's not necessary. We need two lines. And somehow we cannot data in linear classification. We need non-linear classification. Networks is a good candidate for. Then we introduce a neuron cell, and then so we can model the neuron, model the neuron, and then introduce the activation function, and so that how the neuron, how the work, and in our body, in another nervous system, explain how or pass through the music in notes is applicable use some ways. This network will be two layers, two nodes. How these neural networks works, and set that example for node 1, and then read to the node 1 of layer 2. And this happens for others, okay, XLS, and for new comes. I will explain. Okay, that networks is known. Neural networks is not a class, okay? It's a method for classification, and of course, neural networks have other applications. The next step of the neural networks we will explain. Okay, hope to watch the videos. Then finally, question. I related to input, W is related to weighting, and then we can calculate the mix of each node. Okay. And then after that we have activation, and this pass through the activation function. For example, if you have segment, we only must use this equation and calculate the output. Explain it again. Okay, no, this is our new. We explain about the pages in audio. And now we want matrix. We have a two-layer matrix. As I said, so the first layer we called it input layer, and the last layer called it contains three layers. In each layer we have three. 1, 2, 3, 1, 2, 3. And other layers between input and output, big layers. In this diagram, we have only one hidden layer. Maybe we have 2, 3, 5 hidden layers. Okay. See again. There are some matrix weights, some connections, node 1 from the hidden layer. The weight is W11. The weight W11. The connection, the weight is W12. Okay. As we said before, because the computer then state this connection in the form of the matrix. Okay? In the form of matrix. For this neural networks, we have a matrix. We have a W matrix. This layer and the second layer, input layer between this W is the connection between input layer and hidden layer. And we have another weighting between hidden layer and output. So the book called it W this up input hidden. Okay, hidden. I don't. In this called it W hidden. Okay, hidden output. Then we have three layers. We have two weighting matrix. This clear. This is the input. Okay, and after we have O means outputs. Okay. The input layer, the nodes in the input layer don't function, but other layers have it. Okay. Okay. Then here you see that W from input here. The first amount is 0.9. It means that we call it W11. It means that the connection between the first node of first layer of hidden layer. Between the second node of first second a node of the second layer we call 2, and this is related to 3. Okay, for example this is the waiting, the third node of the first and node hidden. Okay, in this book this thing was introduced. Okay, no questions. Matrix is between hidden and outputs. This is 1, this is W3.9, 0.9. Again, come back to the diagram. .9 node of hidden third node of the output layer. Our input must put 0.9, 0.1, 0. Okay. Then, according to the previous discussion and study, this is equal to the W input hidden multiplied by I. Then the input connection between the input layer and hidden layer divided by input. After the calculation, the output is this. Exceedent is equal multiplied by this vector. And then equal to this. Rho multiplied by this as this. And this. Okay? Okay. And in this diagram, for example, the first is 1.16. Okay? Then the x here is the x of hidden layer after those calculations. But these nodes have a function. Then the x hidden, the x means this. Pass through the activation function, and here we consider the function is sigmoid, and the sigmoid is yet divided by exponential minus x. Then this, for example, is called O hidden O, and this let me to zoom on it. The output of hidden layer can be calculated after passing the activation function. Okay, then the output of hidden layer is this. It means that for example, for the first one, iterated by in this way. Divided by 1 plus exponential minus this. You can calculate it. The output is, and this is for the second and third. Okay, put it down, calculate. And then in this diagram, you see the output here. Then this output is the input for the third layer. The output of the second layer used for the input the third. The matrix between hidden layer and output multiplied, then we calculate X output. Okay, output. This X output must pass through the activation function. Again, we know the activation sigmoid. A same equation I explain. We pass this from the and is this. Okay. Then in this diagram, you see the outputs. No questions? Things would be clear for you. It is too simple, but only takes time to calculate. Okay? And now, the question. We consider neural networks. After that, we considered a neural network, and we calculate the output. Okay. Now the question is that, okay, calculate the output, how we can update the weighting. Because as you know, we still refer the neural network, and we update it in different steps, and then we feed the test data, and then we run about the calculating the neural, how we can update the weights. Okay. To reach this answer, consider that we have okay. This diagram is used only for after that we use more sophisticated complex neural networks. As you see in the previous video, we said that okay, we have the, for example, for linear classification, we said that okay, we calculate this line, the slope of this line, but we know the slope is this blue one. We know and then step by step we decrease. Okay, we tried to decrease this pink arrow. If we can consider, again I said that we can consider this linear classification like only one, and we want again using the arrows. Okay, that we said that if we know the target, for example, or if we have some examples, if we have the correct value of the outputs, and we know we have inputs, we have some weights, we calculate the outputs. On the other hand, the correct output, the error, but use this output arrow to update the weights, to refine the weighting. How we can use it is that we divide this output equal two nodes. For example, if we call the error capital E, and if we have two nodes, then half of the is related to the first node and the half related to the second node. This is one strategy. Another strategy is that okay, we calculate the error. Okay, but as we see in this diagram, we see that the weighting of the first node is 3, and the weighting of this is 1. that the of the first node is larger than the contribution as the same value, then the effect of the first node is more than of the effect and contribution of the second node. Then we can split, we can divide it this error according weightings. Okay, we can split this error according to the weightings. Another strategy. It seems that the strategy is better. And in this diagram, you can see these two different strategies. If we consider the same contribution, the error in the same value and other, we can split the error according to the weights. For example, here we error for the first node 3 by 4, and for the second node we can set that okay, this contribution of this node is less 1 by 1 divided. Now other hands is that 0.20 5 of this fraction. Okay, and we set the error according and another thing is that you attention, the summation of this fraction is equal to 1. And how we can calculate this fraction? I will explain. In the next, I will explain. Okay. Now, that you have 2 layers with 2 nodes in each layer. Finally, you have 2 outputs. And you can calculate many nodes on in the layer 2 nodes. First, the nodes of the first layer. Then E1 and W21. No, here, okay, intercepts are calculated the difference or the fraction by calculating the differences, but not the fraction. Okay? Okay, insert your name correctly. For example, E1, and now out calculate and target. Target minus the here is the target, and then according to the weightings we split the input to the previous. Okay, no questions? Okay, and again for E2 and again for E2 we split E2 two weights because the frequency both them affect on the second node of the layer 2. Okay, and as you see, Intesa said that okay, E1 is equal to the target one is desired value minus calculated as I explained you before pages. And as you see how we split the error, okay? For example, we said that W11 divided the T W11 and W21. Again, here consider this split E1 W11 divided by W1 plus W21. Two ways that affect on the first node. And W by W11 plus 2. Okay. And both of them multiplied. And for the second, for example, for this line, we say W is divided by W12 plus W22. Why we use this weighting? Because these weightings affects on the second node, and then this multiplied by, and for the second updating, okay, is divided 1 plus W22 multiply. Okay, any questions? Then till now, if you at first we introduce neuron, then we said that each neuron can have activation functions. We consider layers, we will lay outputs. Don't know out is good or not. Okay. Then we consider the targets. We want to update the neurons. We want to update the weightings of neurons. Yes, outputs. The best of that the errors. Okay, and we try to update the weightings. Okay. Okay. Now, in this neural network, with input and output layer, we have target. We have okay, and we this error to the previous layer, and we call this strategy back propagation. We propagate the errors to the previous layer, then because of propagation. Okay. Output layer, we have taught we calculate the outputs. This is between 10 outputs, and we can achieve the errors. But from the how we can back to the field, how because we don't have any target here. We don't have targets for a hidden layer. Then how we can for the errors to the previous ones. Now we want to answer these questions. As you see here, we don't have the error here. Okay. How we can then the error of in the previous pages we said that we split this error according to W12 and W. Okay, and we split this. And we split output according to W12 to W22 using some fractions, some mathematical equation. We split this error and we backpropagate this error layer. Okay. Then now node 1, of the hidden. We have two errors according to two waiting connections. Okay, W11 from this pink and W12 according to this blue one. Then the error here is the sum of relating this and this. And for the second node, again we have these arrows. They affect this arrow, and One of them is for pink and another one is for blue. Then we can sum these arrows. And in this way, we can calculate the error of the hidden layers. Then after that, we backpropagate the error of hidden layer to the input layer, and we update the weights. Okay? And here you can also set that. Okay? The error of hidden layer for the first node is the sum of split errors on links W11 and W12, as I said you before. Okay? Then in this way, for example, using this fraction, you can calculate the error 1 and error 2 for the hidden layer. And then you can continue this backpropagation to the first layer. For example, you use this. You can achieve the errors for the input layers. Okay? Now, we can, in this matrix form, all of the discussion, all of the explanation that I said, we can gather all of them in this matrix equation and set that, for example, okay, error of hidden is the, for example, for the first node, it means that if we open this, error of hidden 1 and error of hidden 2. Okay? The error of the first node and the error of the second node. Then it means that this row multiplied by this column, and error 2 is equal to multiplied by the second row by this vector, the previous equation that I said. Okay? And then totally we can set it, and we can set it, okay, W1, 2, and okay. And as we know, the transpose of location of row and columns change. This row comes to these columns. We know that the second row, the second column, the third row, third column. We called it the transpose of the matrix. Okay, and if you consider here, error hidden is equal to this weighting matrix multiplied by error. Okay, and using the transpose, we can set that the error hidden is equal to W transpose of hidden output multiplied by error output. We can conclude it with. Okay. And the next question said that yes, Naina. The discussion in this all that we go review neural network, and then after that we want to start learning. Yes, we review all the book, all pages of this book. It is too simple. If you attention, we reviewed 18 pages. You are worried. Your questions is that you are worried, and I think that you can't understand the details. One reason for these questions, and maybe you don't have watched the video relating to these books, and I think only one reason. And another thing is that you yourself don't have studied this book. Then maybe you cannot follow the information, the course in this session. Please review it and watch the videos. Okay. Then, in summary, we finish this session. In summary, we can calculate the outputs, and we can learn how to update the weights. But the next question is that how we continue this processing, how many times, and how we can understand that this is good or not. Okay, in next session we will review, and we will okay. Then I recommend you review these pages. It is too simple. Don't worry, please don't worry, too simple. And because don't watch the previous videos, you can't follow the session. The only reason is that. But it is too simple. Then follow the pages and review the pages, 82 pages of Rashid book. If you don't have any questions, finish this. Okay. Okay, thanks for your participation in this session, and thanks for your attention. Bye, and I see most of names here. Okay, please study the books. Bye to all of you, and good luck, and be successful, and good afternoon. Good afternoon, and have a good time. Bye.